Okay, so you guys, I do have all your tests graded, and they should be back. It's your coordinator at your site. So hopefully they'll get those back to you sometime in the next day or two. I'll answer any questions you might have on Wednesday. Now that they're graded, you can redo the ones that you got wrong and turn those back in. So when you do that, just make sure you show your work on them. Okay. Can everybody hear me okay? Hurley, you guys can hear me? Medford? Yep. How about Mawston? Can you guys hear me okay? Okay. I just getting some feedback. I think it might be from Park Falls being gone today. So. Okay. So anyway, like I said, now that you've finished those tests, if you want to redo the problems you got wrong, just make sure you show your work, and you can give them back to your person there, and they'll send them to me, and I give you back up to half your points on those. I believe that there was nobody that did really poorly on the test. In fact, looking at the grades here, if everybody does their corrections, the lowest grade on the test will be a B minus. So that's pretty good for the first test. So I'm really happy with those results. One question that I did want to go over that I think I only had 2 people in the class get right is similar to number 19 on the test, and I'm going to change it just a little bit. Let's say the network discount for office calls is 18%. If the cost of a call after discount is $246, what is the cost without the discount? What most of you did on this was you found 18% of the 246. You found that number and you added it back onto the 246. The problem is when we're dealing with a discount problem like this, and I'm going to write this out. I'm going to make a table here. So we have the full price. From that, we would subtract the discount, and that would give us the network price. I'll put percents on the left and dollars on the right. So obviously full price is 100%. The discount here is 18%, which means the network price, 100 minus 18, is 82%. And the $246 represents the network price. And we want to know what the full price is right here. So I'm just going to ignore this discount for now. So what that is telling me is the $246 that I paid is 82% of the full price. So now I can set that up. 18% isn't what I want because I don't have the full price. I don't have what represents the 100%. So I have to work with that complement. 100 minus 18 gave me 82. That is the network price after discount. And the $246 represents that network price after discount. So now if we cross multiply and divide here, we will get $300 is the full price without the discount. So like I said, I think I caught all of you but 2 on that one. But that was the only problem that consistently gave people troubles. So like I said, on Wednesday, once you've had a couple of days to look over the test, if there are still any you have questions on, let me know and we will go through those in class. Okay, we left off on Friday. We were talking about some basic algebra, solving equations. So what I want to look at today is some basic word problems, and then I want to get into mixture problems, which is going to be kind of our big topic for the day. So to start out, dealing with word problems, we have three main types of word problems. Either we have type 1, where we have two amounts that have to add up to a total. The second type we have is we might have two amounts that subtract to give us a known difference. Or we can have two amounts that have to be equal to each other. So the first, pretty much all of the word problems we do where we rate algebraic equations are going to fit into one of those three types. So let's look at a fairly simple one here. Let's say that Sam sees 3 times as many patients as Pat. If they see a total of 84 patients, how many did each see? So here we have a case where we're going to add up. We're going to see the number seen by Sam plus the number seen by Pat have to add up to a total. That total is given as 84 patients. So we've got to figure out some way to express the number seen by Sam and by Pat. Well, in a problem like this, we can't have two variables because we don't want to work with a system of equations. So looking at it, we have to figure out which one of those can be expressed in terms of the other. What one variable can be used to represent both of them. And if we look up here, we see Sam sees 3 times as many as Pat. So what that's telling us is if we let the number seen by Pat equal x, the number seen by Sam would be 3 times that, or 3x. So we've now represented both of those with the same variable. And now we can just go ahead and combine 3x and x give us what? Three x plus x is 4x. Good. And now that we've combined them, we can solve the equation. What do we have to do to solve this? Divide by 4. Thank you. So x equals 21. Now we have to be careful. Once we solve the equation, it's really easy to think, oh, I'm done. I've done the hard part. But we have to make sure we go back and answer the question. The question here was how many did each sell? Well, x equals 21. X represented the number Pat sold. So Pat saw 21 patients. Sam saw 3x. So 3 times 21 is 63. Sam saw 63 patients. Now there are different variations on that. I'm going to go to an example that's not quite medically related. Let's look at, well, let's do this. Let's do a similar one. Let's say that Peyton sees 4 times as many patients as Alex. If Peyton sees 27 more patients, how many did each see? So once again, we're dealing with two people here. We've got Peyton and Alex, but we're not dealing with them adding up. Peyton sees 27 more than Alex. So what we're looking at is a difference here. We have the number that are seen by Peyton minus the number that are seen by Alex. Has to give us that difference, which is 27. So whenever we know the difference between them, we've got to be thinking about subtraction. So now once again, we've got to represent them both with the same variable. Peyton sees 4 times as many as Alex, so we'll let the number seen by Alex be x. Peyton will be 4x, and that still equals 27. So if we can combine here, 4x minus x gives us what? 3x. Good. So 3x equals 27. And then what do we have to do? Divide by 3. So we get x equals 9. What does that tell us? Well, x tells us how many patients Alex saw. So then how many patients did Peyton see? 36. Very good. 4 times 9 gives us 36 for Peyton. So let's look at a slightly different application of that. Let's say that Tim sells in the hospital gift shop T-shirts for $12 and hats for $8. Tim sells 3 times as many T-shirts and total sales is, what do I want to put in here? Let's do $440. So once again, how many of each did Tim sell? So this one's going to be a little more complex. I'm going to map this one out a little bit more detailed. So we've got T-shirts and we've got hats. Now, unfortunately, we're not given, if we add up the number of T-shirts plus the number of hats, we're not given that number. But we are still going to have to represent the number of each sold. So the number of T-shirts and hats sold, one is going to have to be related to the other. If we look up here, it says 3 times as many T-shirts as hats. So if we let the number of hats sold be x, the number of T-shirts sold is 3x. But now again, we're not given the total number sold, we're given the total dollars of sales. So we need to find the dollar amount of sales. Well, the dollar amount of sales is going to be price times the number sold. So for T-shirts, the price is $12 each times 3x were sold. So 12 times 3x is 36x. For hats, the price is $8 each times the number sold is x. So 8 times x is 8x. So this is the dollars received from selling T-shirts. This is the dollars received from selling hats. That has to add up to our total. So 36x plus 8x has to equal $440. So our next step is combine. What's 36x plus 8x? Somebody said it there, 44x. Good. And then our next step, we need to divide by 44. Great. So we have x equals 10. So x equals 10 tells us he sold 10 hats. How many t-shirts did he sell? $30, right? 3 times 10 is 30. So 30 t-shirts and 10 hats. Now I'm going to do a variation of that same problem. Tim sells t-shirts for $12 again, and hats for $8. Tim sells 40 items for a total of $440. How many of each did he sell? I'm just going to say how many of each sold. So again, we have to look at t-shirts and our hats. But the way they're defined, the number sold is defined differently here. Instead of being told that one sells so many times more than the other, we're just given there's a total of 40 items sold. So if I let one of them be X, now since we let hats be X last time, I'm going to let t-shirts be X this time. The other one has to be 40 minus X. If there's a total of 40 items sold, we subtract the number of t-shirts, that's how many hats had to be sold. So then the dollar amount of sales, again, is price times number sold. So the price for the t-shirts is still 12 times X. That's going to be still 12X. For the hats, they're $8 times 40 minus X. So 8 times 40 gives us 320. And 8 times negative X is negative 8X. So those two have to add up to give us the $440 total. So 12X plus 320 minus 8X equals 440. What's our next step? We're going to combine, good, the 12X and the negative 8X to give us 4X. Perfect. Then what's next? Subtract 320, very good. So 4X equals 120. And then divide by 4. So we got X equals 30. Now this time, this is why it's important at the beginning to make a note of what X is, because this time X was the number of t-shirts. So X equals 30 tells us there were 30 t-shirts. 40 minus X, 40 minus 30 gives us 10 hats. Any questions on those? Okay, now for this class, we're going to focus on what's called mixture problems. So we're going to start out talking about solutions. Solutions are just a form of a mixture where one substance is dissolved into another. And a solution always has two parts. There's a solvent. The solvent is generally the larger of the two. And it is generally inactive. So most of the time it is water. Occasionally it might be an alcohol solution. In this class, we're going to talk about a generic solvent. We're going to use the abbreviation NS. NS can actually stand for a few different things. One of the abbreviations it stands for is normal saline. Normal saline is just pH balanced sterilized water. Or it can be used to mean neutral solution. In other words, a solution that has no medicinal value at all, no medical value at all. So our solvent, as I said, is generally inactive. Generally, it is there. It's what we call a vehicle in medicine. By vehicle, that means it doesn't do anything medically. All it does is it takes the active ingredient, the medicine, and carries it into the patient. So the other part is the solute. And the solute is usually the active ingredient. And it actually hides into the solute, or the solvent, I should say. So the good example of this that you should be familiar with would be salt water. In salt water, the water is the solvent, and the salt is the solute. And if you put the right amount in there, if you stay below that critical amount, the salt actually disappears into the water. You can look at salt water, and by sight, it looks no different than regular water. The salt hides between the particles. So the amount of a solute in a solution is equal to the concentration times the volume. Now it could also be concentration times the weight or the mass. So the concentration, of course, is our percent as a decimal. So let's take a look. Let's say we have 300 milliliters of a 13% solution. The amount of our active ingredient, or the amount of our solute, or medication here, is going to be the concentration, that's the 13%, but we're going to write it as a decimal, 0.13, times our volume of 300 milliliters. That's going to multiply out to give us 39 milliliters of that active ingredient. Well, for our purposes, we're looking at mixing two solutions together. So let's say we mix 200 milliliters of a 21% solution with 100 milliliters of a 27% solution. Let's find the concentration of the result. So here's an example where we're adding two together. We're adding the amount in solution A to the amount in solution B to get a total amount here, to find a desired solution. So solution A is a 21%, solution B is 27%, The amount of solution A is 100 milliliters. Or sorry, solution A is 200 milliliters. The amount of solution B is 100 milliliters. We don't know the concentration of the final. That's what we're looking for. But do we know the amount? Sure. 200 plus 100 better give us 300 milliliters total. So we're looking at having 300 milliliters of our final solution. So let's set up this equation. So the amount in solution A is the concentration, 21% is 0.21, times the volume, which is 200 milliliters here. To that, we're going to add the amount in solution B. Its concentration is 27%, so 0.27, times its amount of 100 milliliters, equals, in the final amount, in the total, we don't know the concentration, so that's our X, but we do know the amount has to add up. 200 plus 100 gave us 300 milliliters. So now let's go through this. We've got 0.21 times 200 is 42 milliliters. So there's 42 milliliters in solution A. 0.27 times 100 is 27 milliliters. So there's 27 milliliters in solution B. Before I move over to the right side, I'm going to combine those. 42 and 27 add together to give us 69 milliliters. Over here, I just have X times 300, which is 300X. And to solve for X, I'm going to divide by 300, which gives me 0.23 equals X. Now, again, we need to go back and look at what does X represent. X represented the concentration of the final solution. So 0.23 means that final solution is a 23% solution. Now, most of the time for us, we are not just going to be randomly mixing two solutions together. We are going to have a desired concentration that we want to achieve. So for us, it's going to be more practical to look at a situation like this, where we have on hand 32% and 44% solutions. Let's say we need or we want a 41% solution. So our question is, how much of the 44% solution do we need to mix with 60 milliliters of the 32% solution to get to the desired 41%? So again, we have two amounts that are going to add up to our total. What percent is the first one of our ingredients? What's the percentage? One of them is going to be 32%. The other one's going to be the 44%. And what percent do we want our result to be? We need 41%. What amounts do we know here? We only know one volume. And which one does that go with? That's of the 32%. So that's 60 milliliters. We're asked how much, it helps if I put the word much in there, how much of the 44% solution do we need to mix? So what we're looking for is the amount of the 44% solution. So I'm going to let that be X. So the question now becomes, how much of the total solution are we going to have? Well, if we look up here, we did 200 plus 100 gave us 300. We're going to do the same thing down here. We have 60 milliliters of solution A plus X milliliters of solution B is going to give us 60 plus X milliliters of our final solution. So now our equation, 32% is 0.32 times the amount of 60. That's the amount in solution A. For solution B, it's 44%, so 0.44. Our amount is X. That's the amount of active ingredient in solution B. That has to equal our total. 41% is 0.41, and its volume is 60 plus X. So now we're going to go ahead and combine what we can here. 0.36 times 60 is, I believe, 19.2. Plus 0.44 times X is just 0.44X. Equals, here we're going to have to distribute 0.41 times 60. I believe it's 24.6. And 0.41 times X is 0.41X. So now we're go about solving this equation. And we have an X on each side. So I'm going to get rid of the smaller one. I'm going to subtract the 0.41X. So it's gone over here. On the right side, all that's left is the 24.6. On the left side, we've still got the 19.2. And 0.44X minus 0.41 is 0.03X. What is our next step? To solve this equation, we would have to subtract the 19.2. So we've got 0.03X equals, that comes out to be what, 5.4? And then what do we have to do? Perfect. Does that divide by 0.03? So X equals 5.4 divided by 0.03 is 180. So now we have to go back and make sure that answers our question. X here represented the amount of solution B, the 44%, and that is what we were asked. How much of the 44% solution? So 180 milliliters is our answer. Any questions on those problems? Okay, let's do another example. Bless you. I'm going to word this a little bit more like the book would. So we're going to ask how much 8% solution should you combine with 120 milliliters of 24% solution to create 12% solution. So what are the 2% that we are combining here? What two are we combining here? We've got three of them in here. We've got 8, 24, and 12. Which two are we combining? Perfect. We have the 8 and the 24. So the result is going to be the 12%. That's what we're trying to create, is the 12%. We know the amount of 120 milliliters. Which one does that go with? Perfect, 24%. So then we're asked to find how much of the 8%, so we'll let that be x. So then the amount of our result is going to be x plus 120. So our equation, 8% is 0.08 times the amount of x is the amount of active ingredient in the first solution. For the 24%, it's 0.24 times the amount of 120. That's the amount in the second solution, equals, we want 12%, so that's 0.12 times the amount of x plus 120. So that would be the total active ingredient, which will be the active ingredient in our final solution. So 0.08x is just 0.08x. 0.24 times 12 is 28.8 equals 0.12 times x is 0.12x, and 0.12 times 120 is 14.4. So from here then we're going to go about getting rid of one of the variables. The 0.08 is the smaller one, so I'll subtract that. So we got 28.8 equals 0.04x plus 14.4. And now, for the sake of time, I'll go through and solve this one for us quick. We're going to subtract the 14.4 to get 14.4 equals 0.04x. And then dividing by the 0.04. If we divide that by 0.04, what do we have? 360 equals x. So what that is telling us, up here, x is describing the amount of 8%, so that's 360 milliliters, and that is what we're asked for, is the amount of the 8%. So now I'm going to show you a variation that's slightly more difficult. Let's say we have 11% and 21% solution. We need 240 milliliters of 17% solution. So the question is, how much of each do we need to combine? So here we are combining 11% and 21% in the hopes of getting a 17% solution. The only amount we know, though, is the 240 milliliters, and that represents which percent? That represents our result of 17%. So we know the total amount that we want. We don't know either of the ingredients. So what we have to do is just pick one of the ingredients to be X. Through my experience solving problems, I've learned that generally, if you let the larger of the two concentrations be X, it helps us not have to work with negatives. So I'll let the 21% be, the amount of the 21% be X. So then how much of the 11%? Well, we know that these two numbers have to add up to give me this total. So this one here, working backwards, would be 240 minus x gives me this amount. So the amount 11% is the 240 millimeters minus x, or however many milliliters of 21% we used. So now our equation becomes 0.11 times 240 minus x plus 0.21x equals 0.17 times 240. So now we have 0.11 times 240 is 26.4. 0.11 times negative x is a negative 0.11x. 0.21x is just going to be 0.21x for now. On the right side, I can go ahead and multiply 0.17 times 240. 40.8, thank you. And now we can combine here. Negative 0.11 and positive 0.21 give me a positive 0.1x. We will subtract the 26.4. So we got 0.1x equals 14.4. If I divide by 0.1, I get x equals 144. So now I go back up and remember what x is and make sure I've answered the question. So 144 milliliters is the amount of the 21% solution. But remember, I was asked for how much of each. So I have to do 240 minus 144 is 96 milliliters of the 11% solution. Anybody have any questions? Okay. Well, these are ones I think that are best if you guys try to solve them on your own. So we will talk more about these mixture problems coming up probably next Monday. So for now, I'm going to have you guys take a look in your book for homework, page 53 through 54, 1 through 15. You have the answers for the odd-numbered problems, but try to give all of them a shot if you would to make sure you've got them down. This is one of those that on the test seems to be one of the most missed problems. So make sure you're getting good at setting up these equations from the problem. Okay, with that, I'll let you guys have the last few minutes to get started, and we'll see you all on Wednesday.